160 to 165. I can't wait. Here we go. Well, 160. Find the missing side. This right away I'm thinking the Pythagorean theorem because it's a right triangle. And the right triangles and the lengths of their sides are related by a squared plus b squared equals c squared. Okay, so the legs are this one and this one. And I just have to do a squared plus b squared for those two. And then this one will be c squared. All right, so if I do a squared, I'm going to pick either one. So I'm going to pick 6 to be a. So that'll be 6 squared plus this one can be our b. So that'll be 8 squared is equal to c squared. 6 squared is 36 plus 8 squared is 64 is equal to c squared. And this adds up to 90, 100. Ooh, that worked out nice. And 100 is c squared. Well, how do you finish? You square root both sides. And technically the answer is the absolute value of c is 10. But in reality, I don't want two answers of 10 and negative 10 because I can't have a side length be negative 10. So I can not worry so much about that absolute value thing and just say that my answer is c equals 10. All right, so that was a squared plus b squared equals c squared to find the missing side. Sometimes they give you the hypotenuse. I'm going to try one like that for you. Let's say it says this is 8 and this is 4, and you got to figure out how long this one is. Well, you can still use a squared plus b squared equals c squared. And you just have to be careful about where you put the a, b, and c. All right, this can be a or b, and this can be a or b, but that has to be c. Okay, so I'm going to put the 8 right there right away so I remember that 8 has got to be c. And I'm going to pick this to be a. So I'm going to say 4 squared plus, and I don't know what this is, so I'm going to leave it as a variable. It's the only variable I have. So b squared and 4 squared, so that's 16 plus b squared equals 64. And then I'd subtract 16 from both sides, and I'd have b squared is equal to, let's see, that's like 60 minus 12, which is like 50, minus 2, which is like 48. Okay, and then b must be the square root of 48. Well, let's see, what's that close to? Square root of 64 would be 8. Square root of 49, ooh, it's really close to the square root of 49. The square root of 49 would be 7, and this is a little less than 7, so I'm going to say that b must be about 6.9. Okay? All right, so there's how you use the Pythagorean theorem in a couple different examples. Moving on. Find the degrees of the angle. All right, the question mark must be what they're asking me about here. So in these kind of problems, you've got to know that this angle and this angle will add up to 180. And so I can, that's called supplementary. These angles add up to 180, so this one must be 70 degrees. Okay, and the one right here, the 110, is right exactly across from another angle that will be exactly the same size. These are called vertical angles to each other. So that one's got to be 110, all right? And we figured out this one was 70, right? So this one's also 70 over here, okay? And then these four angles are all going to be the same, relatively, okay? So then the 110 goes here. You see what I'm saying? This one and this one go together. And this one's the smaller, kind of like that one is. So that one's 70, and this one's 110, and this one's 70. See how those work? So my answer for my question mark is 70. And I can get it via using logic and vertical angles and supplementary angles. And I hope you get that. Let's move on. Find the degrees of the question mark angle. Well, this is just trying to get at the three angles in a triangle always add up to 180. That's the point here. And it's always true for any, not just right triangles, any triangle. They'll add up to 180. So that one would have to be 50. Otherwise, it wouldn't add up to 180. So this one must be 50 degrees. That's all there is to that. Moving on. Could these three sides make a triangle? 1, 2, and 3. All right. Well, we're not talking about a right triangle. If it was a right triangle they were asking about, we would try to use 1 squared plus 2 squared equals 3 squared. And that would not work. Okay, but the question here is, could these even be a triangle at all? And this is an important thing, especially on the SAT and ACT tests. They want to make sure that you know that in a triangle, if you have two sides of the triangle, the two sides of the triangle that are the smaller side, not the hypotenuse, but but the two smaller sides, the legs, those together, if they just equaled the length of the hypotenuse, like this one does, like the 1 plus the 2 together, if they just equal the third side, then this would be like a triangle that wasn't even opened up at all. There would be no angle here. See, these would be like compressed down and squished so that it would be right on top of the hypotenuse. So that couldn't form a triangle. It would basically just make a straight line. It would be like the three sides of the triangle, and the last side has got to like connect here to here, and it's flat. All right, so if this is 1 and this is 2, this can't be 3. It has to be more than the two sides put together. So what they're trying to say on a triangle is if you take the two smaller sides of the triangle, they have to be more than the third side. Okay? So if I give you three sides, 5 and 12 and 15, could those possibly be three sides of a triangle? Not a right triangle, but a triangle. Well, if I take the two smaller ones and add them up, they have to be bigger than the third side. And they are, because it adds up to 17, and 17 is bigger than 15, so it would be okay. These could be the sides of a triangle. All right? Moving on. If the circumference of a circle is 8 pi, what is its diameter? All right. Well, anytime they're talking about a formula, something that I know a formula for, I'm going to write that down. And so circumference of a circle is 8 pi. So they're talking about circumference and diameter. So I'm going to use circumference is equal to pi times the diameter. That's a formula that I know, and I hope it's going to come in handy here. Circumference of a circle is 8 pi. So under my circumference, I'm going to put 8 pi is equal to pi times the diameter. Well, the pi is not a variable. Pi is a number, and so I've only got one variable left, so I can solve for d. I can solve for my diameter now. So if I'm trying to get d alone here, I got to get rid of the pi. So I'm going to divide both sides by pi. So I'm going to make it like a fraction, but over pi and over pi. And so my pi's cancel, and my pi's cancel again, and the diameter must be 8. Didn't that one work out kind of slick? All right. So the point here is that you need to, if you ever have a chance to, use a formula. If you have a formula to start with, and then you can plug things into that formula, that is a classic problem to solve in math. All right, our last one for this section. A cube has side length of 3. What is its surface area? All right, in a situation like this, instead of drawing the formula, I'm going to draw myself a picture of it first, okay? And it's a cube with a side length of 3. So this is 3, and this is 3, and this is 3. All the sides, all the edges are 3. What's its surface area? Well, there is a big long formula for surface area, but I'm going to just go with the simpler thing, and that's that on a cube, you have 6 sides that are all the same, okay? And I know what the area of one of the surfaces is, and then I just have to times that by 6, all right? The area of this side right here would be 3 times 3 makes 9, okay? So 6 sides, and the sides are each 9. So 6 times 9 is 54. And remember, when you do area, we're doing in square inches or feet or miles or whatever. This one's inches. So 54 square inches. Again, there's 6 sides, and they're 9 square inches each. So then it's going to be 54 square inches. All right. That's all I got for you on that one.